Alright guys, final section here for chapter 2. We have 2.10 perpendiculars and distance. This lesson also includes parallel lines and the distance between them, but we're not going to do that. We're just going to focus on the perpendiculars. So we're only going to focus on objective 1 there, finding the distance between a point and a line. Okay, so a little bit of review before we get into this. Number 1 is the distance formula. So if you remember on the distance formula, it's just the change in x squared plus the change in y squared, and we take the square root of that. This was derived from the Pythagorean theorem, right? So this format here is a little funny, so let me just rewrite this. The distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Make sure you have that in your notes if you don't have that memorized yet. Then for parallel lines, we know that their slopes are the same. Okay, so this is just a review from what we've been doing here in the last couple of sections. And then the perpendicular line slope would be flipped and switched, right? So flipped and switched is what I like to say. For instance, if I have a slope that is 1/2, the perpendicular to that would be flipped, which is 2/1, and then switch the sign, so -2, right? So just a review on that. Let's get into it. So how many lines can pass through the point that is shown here, this blue point, and be perpendicular to the existing line? Well, we know that a perpendicular by definition has to meet at a 90-degree angle. So there would be only one line that meets the other line at a 90-degree angle. There's only one possibility. And it turns out that that straight line at a 90-degree angle is the shortest distance. This is the shortest distance between that point and that line, the one that meets at a 90, the perpendicular. Okay, so we're going to focus on finding that distance today. That's what our goal is. So here we go. The perpendicular postulate states that if we're given a line and a point that's not on the line, then there exists exactly one line through the point that is perpendicular or meets at a 90-degree angle to the given line, like we just showed. All right, so make sure you get that into your notes. You need to pause this here, write that down. So here are the steps for today here, guys. This is what we're going to do. So there's only 4 problems, I believe, on the homework that I give you, but here's the steps to doing those. Number 1 is you're going to find the equation of the line given. So they might give you a set of coordinates. You got to find the equation of the line through the coordinates. So again, to find that, right, we're going to find slope. The slope is simply y2 minus y1 over x2 minus x1. We're going to use our slope. We're going to plug it into either point slope form, or you can plug it into y equals mx plus b form, and then we're going to solve for b, right? Or in point slope form, we'll just simplify it and it'll give us the b. Then for step 2, we're going to find an equation of a perpendicular to that line, which means we're going to switch the m that we found in the first step. We're going to flip and switch it, and then they're going to give us a new point. So they're basically going to give us a point that the perpendicular line goes through. So we're going to use our new slope and our new point to create another linear equation. So step 1, we're going to find a linear equation. Step 2, we're also going to find a different linear equation for the perpendicular through the given point. Okay, so this is kind of pulling a lot together here, which is why I only give you a few problems. So I want you to really focus on this. Step 3, we're going to solve that system of equations. So we're going to set, essentially what we're going to do is we're going to set step 1 to equal step 2. That's what we're going to do for step 3. We're just going to set them to equal each other and solve. Solve for the x value, plug it back in, get a y value. And that'll be the coordinate, or the point, at which, so basically here's what we're doing. Finding the slope of this line, right? So who knows what it is, but let's not even give it numbers. So we're going to find the slope of that line. That's step 1. So they're going to give you 2 points. You find the slope, find the equation of the line. Step 2, we're going to find the equation of the line perpendicular through a specific point. So we'll say that that blue point is the point. Okay, so we find the equation for that line. Then we solve the system to see where the two cross. So this is step 3 right here. when we algebraically solve the system of equations, we see where the two lines cross. Okay, then what we need to know, what they're actually asking us today, is for this distance between these 2 points. Okay, so we do all of those first things to find out where that crossing is so that we know the two coordinates. Once we know these two coordinates here, this one's given, this one we find at step 3. Once we know those two things, then we can find the yellow piece, which is the distance. So step 4 is we're going to use the distance formula to determine the distance between the point of intersection, which was step 3, and the point given, which is in the problem. Okay, so let's try one of these out. Here we go. Example 2 says line J contains the points -5 and -5, 3, and 4, -6. So that's like that thing that I just showed you where we just have 2 points here. They tell you where the points are. We got to find an equation for that line. And then we're gonna go through the steps to find the distance between that line and a point 2, 4. So let's find the equation of line J. Okay, so what we have to do is, I give you a reminder here, you have to find the slope and the y-intercept using the 2 points given. So here we go. If I do that, I'm going to do the change in y. So this is y1, this is y2. So I can say, okay, -6 minus 3 over, and then I can do the same thing with my x's, right? So it'd be 4 minus -5, so that'd be 4 plus 5. So I get -6 minus 3, which is -9, over 4 plus 5, which is +9. So that reduces there to -1. Okay, so far what I have from my equation for my line is y equals -1x, or just -x, plus b. I have to find b. So how do I find b? Well, I can choose either one of these and plug it back in. So I'll choose the first one. Okay, so I'm going to plug those things in for x and y. So for the y, we would plug in a 3. And for the x, we plug in that -5. So be careful here, it's -5 plus b. All right, so when I do this, I get 3 equals, that'll be +5 plus b. So to get b by itself, we have to subtract 5 from both sides, and we get b is equal to -2. So for my final equation for step 1, and this is a lot of work, so I give you a lot of space, we get y equals -x minus 2. Okay, we're going to want to hang on to that because we're going to need that. So step 2 now, keep that on the screen there, is we're going to write an equation of the line perpendicular to this thing that we just came up with. Okay, through this point. So they give us a point, and they essentially give us the slope. All right, so if my original slope is -1, right, then my flipped, so you can call it like -1 over 1 if you wanted to. My flipped and switched slope would be then 1 over 1, or just 1. Okay, so my slope for the perpendicular will be just 1, so I can say y equals x, but I need to find out where the b is here. So I need to find out the rest of my equation. To do that, I'm going to use my point that is given. Okay, so this is where this part comes in. I'm going to plug the 2 and the 4 in. So 4 for y is equal to 2 for x plus b. B is then equal to, if you subtract 2 from both sides, b is equal to 2. So now I have an equation for this guy, which is y equals x plus 2. Okay, I need these two equations. That's the first 2 steps. Once I have those, I'm going to set them to equal each other. That's step 3. So for step 3, I put that down here. Step 3, we're going to set these to equal each other. This is the place where the lines cross, okay, wherever they equal to each other. So -x minus 2 equals x plus 2. Let's go ahead and solve this. If we add x to both sides and subtract 2 from both sides, we get 2x is equal to, this goes away, -2 minus 2 is -4. So that means that my x is equal to -2. Okay, so I can now plug that back into either equation to get my y. If I plug it back into either equation, I get a 0. So notice if you plug it into y equals x plus 2, and then you plug that in, so you get y equals -2 plus 2, y is equal to 0. Okay, So the place where these two cross is at -2, 0. Okay, so the goal of the first few steps is to come up with this, because I want to know the distance between this point and the point that is given here. Okay, I know it's a lot to take in. We'll definitely do a homework problem or two together in class. So the final step here in this problem is going to be to use our distance formula with those 2 points. Okay, so we have -2, 0 and 2, 4. We're going to use our distance formula that we reviewed. So the distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so here's x1, x2, y1, y2 to make it easy. All right, let's go ahead and plug in. So x2 is -2. So we have distance is equal to the square root of, so we have -2 minus 2 squared plus, for our y's, we have 0 minus 4 squared. Okay, -2 minus 2 is -4. -4 squared is 16, so we get the square root of 16 plus 0 minus 4 is -4. -4 squared is 16, which is the equivalent to square root of 32. Okay, clearly 16 goes into 32. So we haven't spent a lot of time doing this in Algebra 1, but we did spend some time doing this. If there's a perfect square, we take it out, right? So we know that 16 times 2 is 32, and we know that the square root of 16 times the square root of 2 is 32. The square root of 16 is simply 4. So this is a little bit of a review, but we took the perfect square of square root of 16 out. If you leave it like this, I'll be okay with it, but this is the better answer. This is the reduced answer. 4 root 2 is the distance between the two, the point and the line. Okay, the shortest distance, I should say. That's all I'm going to do for today. So just example 2, we're going to do 4 just like this. Make sure you review this video again if you need to. Review your steps, get this all in your notes, and there'll be one problem like this, I think, on your test. One problem where you show me that you can do this. All right, take care, guys.